Hello, hello. So today we're going to look at exponential functions. So an exponential function looks like y equals a times b to the power of x, where a is the y-intercept or the starting point, and b is your multiplying pattern. So it's like a multiplying growth pattern. And then in order for it to be an exponential function, the x has to be in the exponent. So let's take a look at an example. If we wanted to graph the equation y equals 4 times 3 to the power of x, we know our y-intercept is at 4 and the pattern is changing by multiplying by 3. Now I can make my table by plugging in some values. I'm going to do my work right in the middle. Hopefully you guys can see that. So if I plug in -3, remember that negative exponents mean that you are dividing by that number. So that would be 4 over 3 cubed, which is 4 over 27. So if I plug in -2, I get 4 over 3 squared, which gives me 4 over 9. I plug in -1, same thing, but now it's just 4 over 3. So I get 4/3. I plug in 0. Remember that anything to the 0 power is just 1. So 4 times 1 is 4. I plug in 1, 4 times 3 to the power of 1. That's 4 times 3, I get 12. And last one, let's squeeze it in there. Plug in 2 and I get 36. So notice, I know it's not as easy with the fractions, but notice that the pattern is multiplying by 3. It's more obvious with the 4 and the 12 and the 36. So we're just going to graph them so we can see what an exponential graph looks like. Okay, looks like this. Nice little curve. Okay, so now with exponential functions, there come some word problems, and usually they're stated as an increase on a quantity by some percent. So the way that you figure out what the multiplier is by adding your percentage to 100% and then dividing it by 100. And this is the multiplier for your function. So let's take a look at an example so you can see what I'm talking about. So let's say that we have dinner at Tom's Diner and it costs $8.95 today. Okay, so that's how much it costs for you to get dinner there. And it's been increasing by an average percent of 7 per year. So notice that it says that it's increasing by some percent. So we need to figure out our multiplier if we want to come up with some kind of function, which it's going to be exponential. So first we need to take the 7% and add it to 100, which gives us 107%. And then we divide that number by 100 to change it into the multiplier, to get rid of that percent, which gives us 1.07. So that's our multiplier. And then remember that the equation needs a starting point, which would be the $8.95 that it costs today. Let me squeeze that in there. $8.95 times my 1.07 to the power of x. And that would be the function that describes this growth. Okay, now that's for an increase. Now let's take a look at a decrease. So if we wanted to decrease a quantity by a percentage, then we are going to subtract that percentage from 100%. Oh no, I forgot my percent sign. So we subtract from 100% and then we divide by 100 just like we did on the other one. And then this is our multiplier. So let's take a look at another example. So let's say that you have a car that you purchased at a price of $12,250 and it's decreasing by 11% every year. So if we want to find that multiplier, we do 100% minus 11%, okay, which gives us 89%. Divide that percentage by 100 to get rid of the percent, and we get 0.89. That's our multiplier. Our starting amount was 12,250, so it'll be 1250 times 0.89 to the power of x. And that would be the function that describes how your car is losing value by 11% every year. Okay, so that's all for today. Thank you for watching.